For this week, we are going to discuss division of radicals. Before we proceed, let's define first the word rationalization. It is a process of eliminating a radical number from the denominator of an algebraic fraction. We start with case number 1, and this is dividing monomials containing radical expressions with the same index. Here are the steps that you need to follow. Divide the terms before the radicals and the terms under the radical sign if necessary. If the denominator still has radical on it after dividing the terms, then you need to rationalize the denominator by multiplying the radical of the denominator to both numerator and denominator. For our first example, we will have square root of 5 over square root of 7. Notice that 35 and 7 are divisible by 7. Square root of 35 becomes square root of 5. Square root of 7 becomes square root of 1. Our numerator, which is square root of 5, is already in its simplified form. So we copy square root of 5 over our denominator, which is the square root of 1. And the answer is equal to 1. Square root of 5 divided by 1 is equal to square root of 5. So our quotient is equal to square root of 5. For our second example, we will have square root of 42x raised to 4 y cubed all over square root of 6x squared y raised to 4. 42 and 6 are divisible by 6. So square root of 42 becomes square root of 7. Square root of 6 becomes square root of 1. We now proceed to our variable. Square root of x raised to 4 divided by square root of x squared. So square root of x raised to 4 will become square root of x squared, and square root of x squared becomes square root of 1, which is also written as square root of x squared. And that x squared will be written in our numerator. We proceed to our y variable. Square root of y cubed divided by square root of y raised to 4. So that will be written as square root of 1 over square root of y, which is also equal to 1 over square root of y. So our y variable will be written in our denominator. Since the denominator is a radical, then you need to rationalize it. We copy square root of 7x squared over square root of y. Then we multiply square root of y over square root of y. We now multiply the numerators, then the denominators. Square root of 7x squared times square root of y is equal to square root of 7x squared y all over square root of y times square root of y is equal to y. So the simplified form of the given quotient is equal to square root of 7x squared y all over y. For our additional example, let's have square root of 3 over 4 square root of 2. The denominator is a radical. Therefore, we need to rationalize the given. We are going to multiply both numerator and denominator by the radical, and that is square root of 2. So we will now write it as times the quotient of square root of 2 and square root of 2. Square root of 3 times square root of 2 is equal to square root of 6 over 4 square root of 2 times square root of 2 is equal to 4 square root of 4. We copy our numerator, which is square root of 6, over 4 times square root of 4 will now be written as 4 times 2. 4 times 2 is equal to 8. So the simplified form of the given expression is now equal to square root of 6 over 8. When using division property of radicals, you need to take note of this. Square root of the quotient of x raised to 5 and x raised to 7 is equal to square root of x raised to 5 over square root of x raised to 7. But square root of x raised to 5 over x raised to 7 is not equal to the square root of the quotient of x raised to 5 and x raised to 7. Before we proceed with our case number 2, we need to define first conjugate. A conjugate is a binomial formed by negating the second term of a binomial. For example, we get the conjugate of x plus square root of y. The answer is x minus square root of y. Binomials of the form a plus square root of b and a minus square root of b, where a and b are rational numbers, are called conjugates of one another. Take note that in this case, the product of the conjugates is a rational number. Example: given binomial is 2 plus square root of 3. Its conjugate is 2 minus square root of 3. For our solution, we get the square of the first term minus the square of the last term. Or we may show it as 2 times 2, which is equal to 4, positive square root of 3 times negative square root of 3 is equal to negative square root of 9. Square root of 9 is equal to 3. So we have 4 minus 3, and the answer is equal to 1. For our second example, we have square root of 7 minus 5. Its conjugate is square root of 7 plus 5. Square root of 7 times square root of 7 is equal to square root of 49. Negative 5 times positive 5 is equal to negative 25. Square root of 49 is equal to 7. So we will now write it as 7 minus 25. And the answer is equal to negative 18. For case number 2, we will be dividing radicals when the denominator is a binomial. So here are the steps that you need to follow. First, you identify the conjugate of the denominator. Next is you multiply the conjugate of the denominator to both numerator and denominator. Last is you simplify the radical if necessary. For our first example, we will have square root of 5 over the difference of 5 and square root of 5. The conjugate of 5 minus square root of 5 is 5 plus square root of 5. We copy square root of 5 over the difference of 5 and square root of 5. Our numerator and denominator will be multiplied by our conjugate. So we'll have times the sum of 5 and square root of 5 all over the sum of 5 and square root of 5. Square root of 5 times 5 is equal to 5 square root of 5. Square root of 5 times square root of 5 is equal to positive square root of 25. All over 5 times 5 is equal to 25. Negative square root of 5 times positive square root of 5 is equal to negative square root of 25. We copy 5 square root of 5 plus square root of 25 is equal to 5. All over 25 minus the square root of 25, which is equal to 5. We get the difference of 25 and 5, and the answer is 20. So that will now be written as 5 square root of 5 plus 5 all over 20. 5, 5, and 20 are divisible by 5. So it will now become square root of 5 plus 1 all over 4. So the simplified form of our expression is the quotient of the sum of square root of 5 and 1 and 4. For our second example, let's have the quotient of the difference of 2 square root of 5 and 3 and the sum of 2 square root of 2 and 3. The conjugate of 2 square root of 2 plus 3 is 2 square root of 2 minus 3. We copy the quotient of the difference of 2 square root of 5 and 3 and the sum of 2 square root of 2 and 3. The numerator and the denominator will now be multiplied by the conjugate. So we'll have times the quotient of the difference of 2 square root of 2 and 3 and the difference of 2 square root of 2 and 3. 2 square root of 5 times 2 square root of 2 is equal to 4 square root of 10. 2 square root of 5 times negative 3 is equal to negative 6 square root of 5. Negative 3 times 2 square root of 2 is equal to negative 6 square root of 2. Negative 3 times negative 3 is equal to positive 9. All over the product of our denominators. 2 square root of 2 times 2 square root of 2 is equal to 4 square root of 4. positive 3 times negative 3 is equal to negative 9. 4 square root of 4 will now be written as 4 times 2. 4 times 2 is equal to 8. And 8 will now be subtracted to 9. The answer is equal to negative 1. The terms on the numerator will now be divided by negative 1. So 4 square root of 10 divided by negative 1 is equal to negative 4 square root of 10. Negative 6 square root of 5 divided by negative 1 is equal to positive 6 square root of 5. Negative 6 square root of 2 divided by negative 1 is equal to positive 6 square root of 2. And positive 9 divided by negative 1 is equal to negative 9. So the simplified form of the given expression is negative 4 square root of 10 plus 6 square root of 5 plus 6 square root of 2 minus 9.